On October 14, 2025, the Austral Radio Astronomy Consortium published data that should have made global headlines immediately. Meanwhile, the European Space Agency kept its own spectrometric records under wraps for 12 full days. 12 days of institutional silence, while radio telescopes in the southern hemisphere picked up something that shouldn't be coming from a comet. Rhythmic, low-frequency emissions, pulsing between 18 and 47 hertz, like the beats of a mechanical heart crossing the interstellar void. The object in question is 3I Atlas. The 3I stands for Third Confirmed Interstellar Visitor. But here's the problem. Comets don't emit sounds. They shouldn't, at least. And when ESA finally released its data, with no explanation for the delay, the numbers only made everything stranger. What exactly are we hearing at 87 kilometers per second? And why did it take almost 2 weeks for one of the planet's leading space agencies to admit it was seeing the same phenomenon too? Because what comes next might completely change our understanding of who or what is traveling among the stars. The object is moving at 87 kilometers s, that's 194,000 miles per hour, or approximately 3 times the solar escape velocity. For context, solar escape velocity is the minimum required for something to leave the solar system forever. 3I Atlas is doing that with ease. 93. Anything above 1.0 means a hyperbolic trajectory. There's no return. The object passes once and disappears into the cosmos. But 1.93 is extreme even by interstellar standards. Oumuamua, the first confirmed visitor in 2017, had an eccentricity of 1.2. Borisov II in 2019 registered 3. 36. But it was clearly a common comet from another star. 3I Atlas is in that intermediate zone. Too fast to be captured, too precise to be random. 1 AU is the Earth-Sun distance, about 150 million kilometers. So 1.4 AU means the object was 40% farther from the Sun than we are, but still within Mars' orbit. At that distance, a typical comet should be boiling. Volatiles, water ice, carbon monoxide, methane, should violently sublimate, creating that characteristic luminous tail. Models say a comet's surface should reach between 200 and 250 Kelvin. That's somewhere between 70 thercurators and 23 degrees. Cold, but warm enough for cosmic icebergs to start disintegrating. Yet infrared sensors recorded localized zones at 340 K, the equivalent of 67 degrees. That's a hot Earth day temperature, not a block of ice orbiting in deep space. It's as if you heated an ice cube to 67 degrees Celsius and it melted slower than it should. Something is anomalously retaining heat, or generating heat internally, or both. Something is anomalously retaining heat, or generating heat internally, or both. Technically, not sounds in the classical sense. Space is a vacuum. Sound waves don't propagate. Radio telescopes detected low-frequency radio waves, 18 to 47 hertz. When converted into audible signals, a standard radio astronomy process, these waves become deep pulses, almost cosmic subwoofers. 3 independent observatories confirmed this. Chile's Andean Antenna Complex, Australia's Woomera Long Wavelength Observatory, and Argentina's Southern Interferometry Array. 3 continents, 3 instruments, same anomaly. Dr. Helena Moreno, an associate astrophysicist at the Andean Observatory, explained, "We expected broadband noise, chaotic emissions typical of magnetic interactions with the solar wind. What we received was a harmonic series with 2.7-second intervals. This is not chaos. This is mechanical periodicity." 3I Atlas, however, shows stable harmonics, as if something internally resonates. Mechanical resonators, cavities, surfaces vibrating at specific frequencies, produce such patterns. Chaotic outgassing does not. 7-second periodicity remained constant for 96 consecutive hours. Temperature fluctuations, solar wind variations, object orientation changes, nothing altered the pattern. It's as if 3I Atlas has an internal clock. Spectrometric analyses by the Meridian Space Telescope, an orbital observatory for infrared spectroscopy, identified traces of titanium-aluminum alloys on 3I Atlas's surface. Specifically, concentrations were 600% above the expected cometary standard. To grasp its magnitude, comets are ice, dust, and rock. Some contain trace amounts of metal-rich minerals. Titanium and aluminum are rare cosmic elements, not abundant outside of specific processes like nuclear fusion in massive stars, or the unsettling implication, industrial manufacturing. 2 scenarios emerge. First, 3I. Atlas is a fragment of an extrasolar planetary collision. Imagine a rocky planet with a metallic core colliding with another massive body. The exposed, heavy metal-rich core is ejected into space, wandering for billions of years until crossing our solar system. Possible? Yes. Probable? Less than we'd like. The titanium-aluminum wouldn't be a geological accident, but intentional design. Materials chosen for strength and lightness. Armand Leclerc, A geophysicist from Lyons Institute of Comparative Mineralogy summarizes, "If this is natural, we are witnessing a type of celestial body we have never catalogued. If it is not natural, then the question shifts from what to who. There are more than three, and each makes natural explanations harder to sustain." Anomaly 1. Localized thermal signature. Comets heat uniformly as they approach the Sun. Thermal models expect a smooth gradient from the illuminated region to the shadowed region. 3I Atlas exhibits isolated hotspots, areas of 340 K, while adjacent zones remain at 210 K. This suggests internal heat sources or surfaces with highly variable reflective, absorptive properties. No known cometary topography produces this effect. The detected harmonics are at integer multiples of the fundamental frequency, 18 Hz, 36 Hz, 47 Hz, approximately 2.6 times the fundamental. This is acoustic resonator behavior, not turbulent plasma. Probability of natural occurrence on a comet? Preliminary estimates suggest less than 0.03%, 1 in 3,000. Anybody at that proximity experiences measurable deflection. 3I Atlas experienced 18% less deflection than predicted, as if its actual mass were different from the apparent mass estimated by brightness. Either the density is anomalous, or there's a non-gravitational drag effect we haven't yet identified. 3I Atlas shows no visible jets, yet maintains a stable 11.4-hour rotation, measured by brightness variation. For an object without jets, this rotation is too perfectly stable. No precession, no internal atmospheric drag. It's as if it were a solid object, not a pile of icy rubble. Anomaly 5. Light curve with minimal variation. When an irregular body rotates, its brightness oscillates. More reflective areas alternate with darker areas. 3I Atlas's light curve varies by only 0.14 magnitudes throughout its rotation. This implies an almost uniform surface, or a geometry too symmetrical for a comet. Spherical metal-rich asteroids have light curves like this. Irregular comets do not. Data from the UV scan orbital telescope show anomalous reflectance at 285 nanometers, a wavelength absorbed by complex organic compounds, or alternatively, by certain ceramic coatings used in spacecraft atmospheric re-entry. The signature does not match water ice, silicates, or amorphous carbon, so it gets worse. Radio telescopes can pick up terrestrial signals, satellite transmissions, microwaves, even distant lightning. But 3 independent observatories on separate continents with different observation windows captured the same pattern, and all filter known terrestrial radio frequencies before analysis. The 1847 Hz emissions are below the range of commercial telecommunications, usually above 30 nanohertz. The probability of synchronized contamination across 3 locations is statistically negligible, close to 0. 47 Hz is below the commercial telecommunications range, generally above 30 nanohertz. The probability of synchronized contamination in 3 locations is statistically negligible, close to 0. Comets can have active geysers that turn on and off as frozen areas heat and cool during rotation. But 3I Atlas shows no visible tail, has no detectable jets, and its harmonic pattern is too stable. Outgassing is chaotic by nature. Internal pressure varies, surfaces collapse, rates change. No cyclic sublimation model reproduces harmonics with a precision of 2.7 seconds for 4 consecutive days. Ionized plasma from the coma can interact with the solar magnetic field, generating radio emissions, but these emissions are broadband, not harmonic. And 3I Atlas shows minimal coma activity. Without dense plasma, there is no significant magnetic interaction. Each naturalistic explanation stumbles upon the same obstacles: periodicity, stability, metallic composition, absence of standard cometary behavior. 3I Atlas could be the metallic core of a protoplanet destroyed in another stellar system, ejected during chaotic planetary formation. Metallic cores have high density, characteristic reflectance, and could, under specific conditions, develop internal resonances due to thermal cycles. Plausible? Yes. Unprecedented? Also yes. We have never observed a pure interstellar metallic core. It would be the first of its kind. Millions of years in interstellar space would degrade any structure, but core components made of durable alloys could survive. Mechanical resonances could be echoes of ancient systems, propulsion cavities, support structures, even deformed panels vibrating under solar radiation. It would not be an active craft, but a technological ghost. Hypothesis 3. Planetary seed or biologically inert probe. Some panspermia theories suggest that advanced civilizations could send seeds, small protected objects containing prebiotic materials or molecular instructions for life. These objects would travel for millions of years, activating only under specific conditions: proximity to a star, detection of a planetary atmosphere. 3I Atlas could be something like this, not a manned craft, but a passive messenger. And this is where the time window becomes critical. Space agencies embargo data for legitimate reasons: peer review, instrument calibration, anomaly verification before public false alarms. But 12 days is a long time for an anomaly of this magnitude. And when ESA finally released its spectrometric records, they came without an official statement, without a press conference, just a silent upload to the public repository. And when ESA finally released its spectrometric records, they came without an official statement, without a press conference, just a silent upload to the public repository. Transparency in potentially revolutionary astronomical discoveries has been international protocol since the 1967 Outer Space Treaty. Data on objects of uncertain origin should be shared quickly to allow for coordinated global observation. The window for high-resolution imaging of 3I Atlas closes on November 8, 2025. After that date, the object will be 4.2 AU from Earth. That's 17 times the Earth-Moon distance, or about 630 million kilometers. At that distance, even the largest telescopes will only capture blurry pixels. Surface details, thermal variations, spectrographic conformations, everything becomes impossible. What happens in each scenario? This would inform models of planetary migration, exoplanet chemical composition, and increase the chances of finding more such objects in the future. Important for astrogeology, but not revolutionary. Confirmation of extraterrestrial technology, even dead, even ancient, would be the most significant discovery in human history. Not only would we prove that we are not alone, but that other civilizations achieved interstellar travel capability. This would redefine biology, philosophy, international politics, scientific priorities, the Kardashev scale, the Fermi paradox, Drake's equation. All these theoretical frameworks would become obsolete, or finally answered. Now it's to you, if we let it pass without sufficient investigation, we are left with inconclusive data and decades of debate. What if becomes the most frustrating phrase in modern science. All major telescopes with a clear window for 3I Atlas's trajectory should be redirected. Hubble, James Webb, if orbit allows, long-range radio observatories, ground-based infrared telescopes. Telescope time is precious and contested, but this window will not repeat. Protocol 2, rapid flyby mission, feasible only with immediate decision. The last high-speed comet interception mission was Deep Impact in 2005, but 3I Atlas is receding at 87 kilometers. Reaching it would require a launch using the fastest rockets available, something in the class of New Horizons, which reached 16 kilometers towards Pluto. Even then, it would be a flyby, not an encounter. High-speed cameras, mass spectrometers, magnetometers, everything would have to collect data in seconds. But the scientific return would be invaluable. The global astronomical community should establish an open data repository for 3I Atlas. Amateur observatories, universities, space agencies, all depositing spectra, images, real-time thermal measurements, cutting-edge citizen science, as was done with Oumuamua. No single country, no single agency should control the data from an object like this. If there is a chance, however small, that we are looking at evidence of extraterrestrial technology, it belongs to humanity, not to a handful of institutions with large telescopes. Let's return to the heart of the mystery. No unequivocal radio signals, no confirmed artifacts, no megastructures. The cosmic silence is deafening. The chemical composition suggests rare processes or design. Its trajectory suggests an origin in another star system, possibly millions of years ago. Either we are witnessing exotic geology, a type of celestial object that our models do not yet predict, or we are hearing the fossilized whisper of something that crossed the interstellar void with purpose. After that, 3I Atlas will become just another fading point of light, relegated to footnotes in academic papers and endless discussions on astronomy forums. It was going somewhere else, or perhaps nowhere, just drifting like a cosmic message in a bottle, waiting for someone, somewhere, to be looking at the right time. The question is, what do we do with what we found? Or it delivers us the first interstellar artifact in human history, permanently changing our position in the cosmos. If you have a theory, a doubt, or just want to follow this story as it unfolds, leave it in the comments. Subscribe so you don't miss updates, because if something happens in the next few days, you'll want to be here when we report it. Silent, metallic, pulsing at 2.7-second intervals, like an ancient heart that never stopped beating, crossing the darkness between the stars, waiting for someone to finally listen.